Henry here with the tutorials for Class 2 from Intro to Parametric Design at NJIT, where we've moved on from making things or dealing with things to dealing with lists of things. And what I'm going to make right now is a simple ruled surface from scratch. And I'm going to start by creating a series of points from from no Rhino geometry, just purely in Grasshopper. So here in the Vector tab under Point, we can make a point from a series of coordinates. And this is going to be our first list of points. And I'm gonna place them along the X and the Z axis. And one thing that I like to do is when I use a constant like 0, I like to make it explicit. So I'll get a parameter, an integer parameter, I'll name it 0, I'll right click and I'll set its value to 0. So now if I hook that up to all my inputs, I get 1 point sitting here at 0, 0, 0. But what I really want is a list of points. And the easiest way to generate a list of numbers is in the Logic tab under Sets with a series. Series takes 3 inputs. It takes a starting number, it takes a step size, and it takes a count. So the count is going to be the number of points in our list. So I will create a parameter called num points. And let's just attach a slider to it. Well, I'll set that slider to be an integer, minimum of 1, let's say maximum of 25 points. Okay, now these, remember, components always have default values. So the default value is 0. The step size default is 1, so now when I set this to 7, it produces 7 numbers, starting at 0, going to 6, because in computers we always start counting at 0. So what I'd also like is I'd like to be able to increase that step size. So I'll just copy my parameter here and rename it in my slider as well. And we'll call it interval size, because that's going to be the distance in between my points. So now if this is set to 10, it's going to count by 10. It's going to be 0, 10, 20, 30, etc. And if I now hook up my series to X, since what's happening now is my component has multiple inputs. It's got a list of X coordinates. What it's doing is matching to the best it can a list with a singular input for Y and Z, 0, and giving me a series of 7 points. So, 0, 0, 0, 10, 0, 0, 20, 0, 0, etc. Now I could do the same thing. Could just copy this, and instead of hooking the series up to X, I could hook the series up to Z and reconnect my 0 to X. And now I have a list of points in the Z direction, and it's always the same number of points in both, right? And if I go to the Curve tab, I could draw a line between the two. It's no problem. Now if I copy my series here, I could decide that I want to be able to control X and Y, X and Z, my X and Z lists separately. So now, since I've created a second set of sliders, this series is feeding my Z list. If I create more Z points, I all of a sudden have a Grasshopper has a problem, which is to say that it doesn't know how to draw lines when there's an uneven number of points to and from, and there are three options. So this option, what we're seeing, is what's called, if you right-click here, it's called the longest list. So the longest list means I'll draw a point from, now here there are actually 2 points, but they're right on top of each other, but then this point to this point, this point to this point, and I'll keep going, and then when I run out of points in X, I'll just keep using the last one until I run out of points on my Z-axis. If I change that to shortest list, what it'll do is it'll keep going until I run out of points, and then it'll just stop. And if I change that to cross-reference, what it's going to do is it's going to draw a line from every point on the x-axis list to every point on the z-axis list, etc., until all the points are connected to all the other points. In practice, I find that the longest list is what you use most of the time, like 90% of the time. Shortest list is sometimes useful, and the other, let's say, 8% of the time, there's a reason to do the cross-reference, and we'll see an example of that later. In this case, actually, what I want to do, one thing that's often very easy to do, is to just obviate the need to deal with the longest list or shortest list. If I just erase, I can decide that if I just hook num points up to the count over here, that I have one slider that ensures that I always have the same amount of points in X and Z, and I can still control my interval size independently on the Z-axis or the X-axis. I realize I'm going a little slowly, but all this stuff is super important, and it's the kind of thing that you have to keep track of as your definitions get more complex. The one thing, if you know anything about how to make a ruled surface, is the problem that we're having is that what we really want to do is connect this point to this point, and this point to this point. We want to reverse one of these lists. And here it's obvious which way the lists flow. But if you're ever in a situation where you have some doubt, a really good trick is to make a slider and set it to be integer, and set it to go up to some high number or whatever, or maybe just 50 in this case. I always forget where this is. Here in logic, there are a set of operations that operate on lists. So if you go to list item, a list item takes 3 inputs. It takes a list, it takes an item to get, and remember, in computers we always start counting at 0, so the first item in your list is item 0. And if you hook the slider up to I, and if you hook your list, let's use our I'm going to turn the preview off here. My list of horizontal points. All right, if I hook the list up, and then I highlight item, and I drag the slider, I can see which way, that's at the beginning of the list, and that's the end of the list. Now, obviously, you know that by the way it connected the lines, or at least you don't know that, but you know that these lists go in the same direction. Either they both go this way, or they both go that way, right? But now we know they go from left to right. So what you can do is you can reverse this list. It's just another item in the list, and you should go through all of these and see what they do. And if you reverse the list, then what you get is that familiar form, the thing that Xenakis uses for metastasis, and it's how you create 2 lists of points, reverse one list, connect the dots, and there you go.